let's take a look at different types of variables. We've talked a little bit previously about qualitative and quantitative variables, and now we're going to take that one step further and talk about discrete and continuous. Discrete variables have a countable number of objects. For example, if you were to look at the number of apples on the tree, you could count them and say, 1, 2, 3, there are 3 apples on the tree. There's no doubt in your mind. Or there are 5 people in this picture. They're very countable objects. This is in contrast to continuous variables. Continuous variables have infinitely many values. They must be rounded at some point. For example, your speed. You might look at this speedometer and say that you're going, if you were the one driving down the road, you might say you were going a little bit under 55 miles an hour. We'll call it 54. However, the cop with the radar gun who's sitting on the side of the road might clock you in at 54.3 miles per hour. Might be a little bit more accurate. You could probably go to car testing laboratories where they could clock you in at 54.32 miles an hour. Different instruments have different levels of accuracy. So because we can't get a really good handle on how fast you're going without having to round at some point, the instrument we're using must round the value. This is a continuous random variable. The same with weight. Weight, you stand on that scale. Some people's scales might read in at 130, while others might read in at 129.5. That would round up to 130, but that scale's a little bit more accurate. Others might read in at 129.57. Okay? The different levels of accuracy have to be rounded somewhere. We could keep getting more and more instruments that could be more and more accurate, but we do have to round. Age is a confusing one because many people will say, hello, nice to meet you. I am 30 years old. Did you round that value somewhere? Are you exactly 30 years old to the second? Or are you 30 years, 2 months, 3 weeks, and 4 days old? Where do you round? How do we round that? And it's interesting that we round at different points depending on what age you are. For small babies, we often say, she's 6 weeks old. Or even newborns, they're 3 days old. Right? We round to days or weeks when they're very young. And then we might go up to, oh, they're 11 months old. And then we might go to 2.5 years or 3 years. And then as we get older, we really have no idea how many weeks or days or how many months old we are. We just say, we're 45. You know, we rounded to the nearest year. So anytime you must round your value because you cannot measure it precisely to a countable outcome, it is a continuous random variable. Continuous random variables do have conditions with them often. For example, we might say our speed as a condition has got to be greater than 0. You cannot be going negative 10 miles an hour. The greater than 0 is a very, very, very common condition to have for a lot of continuous variables. For example, your weight can't be greater than 0 or less than 0, can't be negative. Your age can't be negative. So the conditions for all of them might be greater than 0. We could have some conditions on the top value as well. If you wanted to, if you wanted to have a car and you knew what its top speed was, I'm not quite certain what this car is, but for some cars they might have a top speed over which they might just not go any faster. So the speed might be limited to something like between 0 and 100. It's between less than 100, less than 100, and greater than 0. So there's often conditions placed on continuous variables, even though we cannot get a countable read on their outcome.